Hello, folks. This is the second in the series of gyroscopic shorts brought to you by Bristol Ground School. My name's Andy Sinclair. In this video, we'll be looking at the turn indicator and turn coordinator. In the last short, if you remember, we discussed gyroscopic precession and rate gyros, which we said had 1 degree of freedom, meaning that the gyroscope's gimbal could freely move in one plane only. A quick reminder of the application of gyroscopic precession. When an external force is applied to the mass of a rotating gyroscope, then the effect of the force is seen to act at a point on the mass which is 90 degrees ahead of and in the direction of rotation, the point of application. Let's have a look at that. In this animation, the mass is mounted in the gimbal and has a vertical plane of rotation, turning in a counterclockwise direction around its horizontal axis of rotation. Now, if we prod the left-hand side of the rotating vertical mass with our disembodied finger, then it isn't the left-hand side that moves away, as we may intuitively expect. Instead, it's the bottom of the rotating vertical mass that moves away from us. Now, in this next animation, we'll apply that to a turn indicator schematic. The turn indicator in the aeroplane indicates yaw around the aircraft's normal axis when the rudder pedals are depressed. As we depress the left rudder pedal, the movement of the aircraft around the normal axis will result in a force being applied at point A. By the magic of gyroscopic precession, however, the force will act 90 degrees ahead of, meaning in this case, in a clockwise direction around the rotating vertical mass at point B, thus causing the gyroscope to move in its 1 degree of freedom, this movement then being mechanically connected to the display presented in the cockpit as a rate of turn. Now, let's look at an animation of a real instrument. In this animation, as we depress the right rudder, the aircraft yaws around its normal axis to the right, which results in a force at the front of the rotating vertical mass. As the aircraft, it pulls the mass around the corner. By the magic of gyroscopic precession, however, the resulting force acts at the top of the rotating vertical mass. This is then mechanically connected to the display and shown as a yaw to the right. I say force here, but for the physicists out there at least, actually what is happening is that the mass wants to continue in a straight line, but it is the yawing force resulting for the application of rudder, which pulls the gimbal around the corner with the aircraft, whilst the mass tries to continue straight ahead. It exercises its 1 degree of freedom movement to do so. This is the same as saying that centrifugal force isn't, rather the centrifugal effect is simply the removal of the centripetal force. This should keep the fans of Isaac Newton happy. The display in the cockpit is graduated with 1 mark that indicates a rate 1 turn, meaning a turn of 360 degrees in 2 minutes, 180 degrees in 1 minute, which equates to 3 degrees per second. This rate of turn is standard in instrument flying, and it is the retaining spring shown in the previous animation that provides the calibration so that the rate 1 turn is correctly displayed. The concept of degrees of freedom is sometimes difficult to understand and visualize. In this animation, when looking at the instrument from the front dial side, the left and right side of the horizontal gimbal are free to move up and down. That is what we mean by free to move in one plane and having 1 degree of freedom. If the front and rear of the horizontal gimbal were also free to move up and down as well, then this would be a 2nd degree of freedom. The gimbal in this instrument only has 1 degree of freedom. One of the problems with the turn indicator is that it only reacts and displays yaw. An evolution of the turn indicator is the turn coordinator, which is sensitive to the initial direction of the aircraft's roll or bank and displays that along with the rate of turn. This is done by angling the gimbal up at 30 degrees to make the instrument sensitive to the precession forces associated with both bank and yaw. The cockpit display consists of a small aeroplane symbol which shows the direction of the bank and the rate of turn, but not the bank angle, or indeed any pitch information. I hope you found this short useful. Next time we'll look at how gyroscopes are used in the other gyroscopic instruments commonly found in the cockpit. Cheerio for now.